Example number 4. Sketch the graph of the function f of x equal x cubed over x squared plus 1. Step number 1, we find the domain. The domain for the function f of x is all real number because in the bottom is always positive for any value of x. Step number 2, we find the intercept. If we find the x-intercept, we will let y equal to 0. And that means x cubed over x squared plus 1 equal to 0. It means x equal to 0. And to find the y-intercept, we let x equal to 0. Then f of 0 equal to 0 also. So the point 0, 0 is the x and the y-intercept are both. Step number 3, we will check for the symmetry. We will replace the x by the x negative. Then we get negative x cubed. And then negative x squared in the bottom plus 1. So we get x squared plus 1 in the bottom. So what we see is here is the f of x. So this is negative f of x. So by definition of the odd, we conclude that f of x is odd function. And because it's odd function, it will the graph will be symmetric with respect to origin 0. Step number 4, we find the asymptote. So f of x equal x cubed, x squared plus 1 in the bottom. To find the vertical asymptote, we're looking for the 0 in the denominator, but the denominator will never be 0, so none. For the horizontal asymptote, we take the limit as x approaches to infinity of x cubed over x squared plus 1 is equal to infinity. So no horizontal asymptote. Now check the slant asymptote. And when I said about the steps, I also explained before that when the dd on the top more than the dd in the bottom 1 unit, so 3 and 2, so 3 is more than 2 1 unit, we will have the slant asymptote. In order to get the slant asymptote, we will divide. So x squared go to x cubed is x times. Then we will get 0 here and then minus 1. Sorry, minus x. So the function f of x can write as x minus x over x squared plus 1. So the slant asymptote is y equal x. Step number 5, we will find the increasing decreasing interval. Now let's find f prime of x. We use the chain rule on the x squared plus 1 and also the quotient rule. So we have x squared plus 1 times 3x squared minus chain rule for the x squared plus 1. So we will get 2x. Oh, by the way, this is not chain rule. This is not chain rule. So times x cubed. So x squared plus 1 squared in the bottom. For the top, we will distribute and open parenthesis. So we will have 3x to the 4 plus 3x squared minus 2x to the 4. So x to the 4 plus 3x squared, and then x squared plus 1 squared. We pull out the x squared, so we got x squared plus 3, x squared plus 1 squared. The bottom cannot never be 0, so to find the 0 of f prime of x is only 0. It's just 0. So if you put the 0 in the middle and you check the side, it's positive both. So the function f of x is increasing from negative infinity to positive infinity. We don't have increasing, decreasing, and so on. So in step number 6, we can say that there are no local max and also no local min. Step number 7, we find the concave upward interval and concave downward interval by taking the second derivative. So we use the quotient rule again. So we will get x squared plus 1 squared, 4x cubed plus 6x minus x to the 4 plus 3x squared times 2 x squared plus 1 and then 2x. We notice that we have x squared plus 1, x squared plus 1, and x squared plus 1. So we can take out the x squared plus 1. So the first x squared plus 1, we still have 1 left. And then 4x cubed plus 6x minus, I multiply this and this because the x squared plus 1 is gone. So I will have 4x and then times x to the 4 plus 3x squared. Now I can cancel the x squared plus 1 for top and bottom. So I will have x squared plus 1 to the 3rd power. And then I will distribute 4x to the 5th inside the bracket plus 6x cubed plus 4x cubed plus 6x minus 4 to the x to the 5th minus 12x cubed. The x to the 5th power is cancelled out, and the x cubed, this is 10, and then minus 12, so that would be negative 2x cubed, and then plus 6x. We can factor out the 2x, then we get negative x squared plus 3, and then x squared plus 1 to the 3rd power. F double ram equal to 0 when x equal to 0 and x equal plus minus square root of 3 for the top, right? Because the bottom is never 0. Now we plug them on the number line and we are checking the side for F double ram. So we will plug in the point. For example, right here, this is like a negative 1.7, so you can put in like negative 2, negative 1, 1, and 2. Okay, so we will get plus in here, minus here, plus here, and minus here. So we will have concave up, concave down, concave up, concave down. And since we have concave up and concave down, so the point like square root, negative square root of 3 and positive square root of 3, also 0, they are inflection point. So when you plug in negative square root of 3, so you will get negative 3 over 4 square root of 3. Input the 0 into the function, you will get 0. And then when we input square root of 3, we will have 3 over 4 square root of 3. So these are the inflection points. Now the last step is step number 8. We will do the graph. So we have y and x. Now we plug in the, first of all is the x-intercept and y-intercept, which is 0, 0. We have the asymptote, so we do need to wrap the asymptote. So the asymptote is a slant asymptote, so y equal to x. So this is the equation, linear equation. When you input 1 on the x, you get 1 on the y. When you input 2 on the x, you get 2 on the y. When you input the 0 on the x, you get 0 on the y, and so on. So x and y are always equal. So we get this line, right? So this line is the slant asymptote, y equal to x. Now we plug in the point, so we have 0, 0 is the x-intercept, y-intercept. We do not have the local max, local mean. We have the inflation point, which is positive square root of 3. So let's consider this point is like square root of 3 and negative square root of 3. Then we have 3 square root of 3 over 4. So that's something like this. Something like this, right? Okay. And then we will connect them and also remember the increasing, decreasing. The graph is always increased. Now we want to check the concave interval. From negative infinity to this part right here is concave upward, concave upward. And then from negative square root of 3 to 0, which is the interval from here to here, we will have concave downward. So we have like this. And then concave upward. And then concave downward. And we also have to draw the graph approach to the asymptote. And the graph show that is always increasing. And of course, if we want more exact, better graph, we will make additional points.